All right, let's move right on to part two. Quick. With these dice, I can create truly captivating games, the kind that make people forget all about the money they're quietly losing along the way. One such game will definitely be a race. Several players take part, each placing a bet on who will win the race. Every player selects one of the dice prepared for the game. The players see the dice as identical, as they only differ in seed value. But of course, I'll know the outcome of the race from the very start. This means I can ensure that my bets with the participants are perfectly balanced in my favor. The racetrack is a sequence of random numbers ranging from 1 to 9, matching the possible outcomes of a die roll in this game. Each player places their token on the first space of the track, starting from the left, and takes a roll of the die. If the number rolled matches the number on the space they're currently standing on, they may move forward to the next space. The winner is the first player who passes the last space on the track. I need to practice simulating races based on the player's set of dice and the layout of the track. Your notes. If I can predict the order in which the players will finish the race, I'll have no worries when it comes to monetizing the idea. To avoid unnecessary arguments, the set of dice I prepared will ensure there are no ties at the finish line of the race. Oh, very clever. So all the dice have faces 1 to 9. They just have different seed values. Okay. All players roll a die once per turn. Below is a list of turns which at least one player rolled a value matching the number of their current placement on the racetrack. Such values are shown in square brackets. Okay, but sometimes you can have two, like this line here. There's two players who get to advance. Finishing order is as follows: 1, 3, 4, 2. What is the finishing order the players provide? The answer is a comma-separated list of players' dice IDs. Okay, this is where we need the IDs. But the IDs are always in order, so, what's this number here? Oh, this is the track. This is the track. Okay, they have to go 5, then 1, then 2, 5, 7, 8, 4. Okay, and now you can see it here, 5, 1, 2, 5, 7, 2, 8, 4. Same with this, same with this, same with this. Got it. All right, so let's grab our download. Move that. Cat it out. Okay, so it's a much longer track, and there's 9 dice, each with its own unique seed. And I'm guessing these are all primes. So for part 2, we can't do it this way. We have to say read records. And then say records 0 dot split on new line iter. Records. Really? Read num records. I thought I had to read records. Let's take a look at this. Now I've read lines. Read text records. That's what I have. Oh, records. And now we should be able to print this. But we don't need to do this. We just need to say records iter. Oh no, we do. We just need to say split on new line. There. Remove mute. That's okay. And if I hit run. Okay, so now we have the dice from part 2, all 5 of them. I remember seeing 5. Okay, and then the last line is this, this last record, which is going to be, I think it has a new line at the end. Let me just double check that. If I say print this out, as record 1. Oh, because, yeah. There were 9 dice. That's what, okay, I should have, I'm going too fast. There were 5 in the first one. But yeah, this one has 9 dice. Oh, and it fits exactly on one thing. Nice. Okay, there is no new line at the end. So we don't have to worry about that. So we just need to convert the records into, you could say, track is equal to records of 1 chars map ch dot, let's say ch as u8 minus 0, and make this all I64, and then collect that into a vec. And we're not using dice or track yet. Okay, so now what you need to do is loop over the dice, roll each one, and each one's going to have a position now. Let's do it this way. Let's do it this way of usize die. We'll just store it here. We don't have to be fancy and stick it in the die itself. And just say 0, yeah, 0 comma this thing here. Right? So this will be the position on the track, and we'll be able to just update that as we find it. Let's print that out. Look, printing things out. Take a look, yeah. So they all start with 0. And we can say, let's do this. Let mute on track is equal to dice len. So the number of dice that are still on the track is this value. And we could say while on track is greater than 0, or not equal to 0. While there's still dice on the track, we're going to keep looping. And what we'll do is we'll roll each die. For die in dice iter mute. And it's not this, it's position and die. Right, so this is the current position it's on. We say let roll is equal to die roll. This will give us our, it's an I64. Because it's an I64. Dang it. It's always going to be positive because we know that all the dice have sides 1 to 9. The reason I'm hesitating is because I need to compare it. Oh, no, I just need to compare it to this thing here. Okay, yeah. We can say if the roll is equal to the track of position that we're on. Oh, yeah, I think I need to do this here. All right, die pause. So we'll say die pause, die.1 dot roll, and die pause. So die pause 0. There we go. Okay, now I think we can do it. If it's equal, then we want to increment the die position, or the die's position on track. We say die pause 0 plus equals 1. Is this a reference? It is. So I have to do that. I probably have to do that. Right? And then we can say if we're at the end of the track, we subtract 1 from on track. And we add ourselves to this list of finishing orders, which I forgot to set up. Okay, so we can say if die pause 0 is greater than or equal to, sure, track len, then on track minus equals 1. And we'll say, let's say finish push of the die's ID. This is where the ID comes in. Die pause 1 dot underscore ID. Right? We could have done an enumerate here and gotten it that way, but we have the ID now. So let's rename it. So it's ID. And then this should be, I'm just going to print out the finish. Oh, we have to actually create the finish. Let finish is equal to vec new. You can print them out this way, but there are going to be spaces between each one. Finish. And this comma separated list does not have spaces. All right, so what's bad here? You says, oh, interesting, right? Iter mute. This should be equality, right? And main panic because the len is 1,000, but the index is 1,000. Oh, we need to keep track of, yeah. So we don't want to roll unless, if we're finished. If we can say filter here. Filter D, or die, right? This is the die. Oh, it's usize die. Okay, so underscore die. Oh no, yeah, we don't need that, right? Position underscore like that, and then say position is less than track len. Position is less than track len. Okay. There we go. Okay, so this is our finishing order, and I think I could just type this in. The thing is, if it's correct, then it's going to show me part 3 right away, and I want to get this to be printing. I want to print this finish out without the spaces and without the square brackets, obviously. So, oh, you know what we could do is just change this here to make this a format. Make us a string. I'm saying format because that's what we're going to do here. And do that. And then we still need to remove the brackets, right? And I think we can just say this, finish, join, comma, right? Yeah, okay. And then just say part 2 equals. All right, so let's see if this is the right answer. Hopefully it is. I quacked it out of the park. Yay.